If it's insoluble in water, there are some exceptions to this. For example, it can be having ethanol. Ethanol is pombe ya kawaida, the inatengeneza pombe ya kawaida, that is ethanol. And some such as ammonia and hydrogen chloride gas that react with water as they dissolve. The reason this dissolve, they react with water. Ethanol react with water as it dissolve. Ammonia react with water and as it dissolve. And hydrochloride gas react with water as it dissolves to form hydrochloric acid. So the next substance that you are going to look at, so sorry, like we said, this combined molecular substance tends to be insoluble in water, except for some cases. But the covalent molecular substances are often soluble to organic solvent. What are these organic solvents? Give me one type of organic solvent. One organic sulfate is methyl benzene. Methyl benzene is an organic solvent of which the methyl benzene is an organic solvent, and this organic solvent is covalent molecular substance, often dissolved or often soluble. So that is for simple molecular structure. Now we want to look at the giant covalent structure. And this, for this case, we are going to look at the example. Very important example. We're going to look at diamond. Diamond is a form of pure carbon. Diamond is also a carbon. Yeah. So, but this one, diamond is very hard. Why is it very hard? Because it has a giant covalent structure. We can say each carbon atom has 4 electrons.
And it also comes from space.
No, if carbon come from the dead organic compound, dead living things, dead plant, when they get buried to very deep in the soil, that pressure and that intense temperature convert this to form carbon, to form diamond. So the way coal is formed, the way graphite is formed is the same way that diamond are formed, but diamond are exposed to intense temperature and pressure when they get buried deep into the earth. So, and we say this is a pure carbon. It's a pure carbon, but does it have noble gas electron structure? Yes, it's going to have a noble gas electron structure because carbon requires 4 electrons to be stable. It can't be stated as unstable. So for this to happen, it's going to form covalent bonding between carbon. So a carbon is forming a covalent bond with other carbon. So each carbon atom has 4 electrons in its outer shell, and therefore form 4 covalent bond. Why 4 covalent bond? Because each carbon requires 4 electrons to be stable. So it's sharing with 4 carbon to be stable, and the other carbon form another 4 carbon. So at the end of the day, they are going to form an address chain. They are going to form an address chain. Therefore, they are going to form an address chain which has 4 covalent bonds. In diamond, each carbon bond strongly attracted to 4 other carbon atoms in tetrahedral arrangement. Tetrahedral arrangement. You can see at this figure, shown there.
Sir,
yes.
It just froze in a moment. Hello.
Yeah, I'm listening. So I'm saying now each carbon is attracted to 4 carbon atoms for it to achieve the noble gas electron structure. And you can see the first figure is 1 carbon. You can see, let me highlight something. So the central carbon is attracted to this carbon and this carbon and this carbon and the other carbons. Those are the 4 carbons. But does this have the noble gas electron structure? No, because it just have 1 bond. Yes, the middle one is stable. The middle one is stable because it's attracted to 4 other carbons. But what will happen to this one?
So even this one.
Yeah. So what will happen to this
The
one?
middle one.
Yeah, even the middle one is stable. So this one will have another 3 bonds. So as we can start, we can say if this one, so this, let's take this shape we bring to here. So this is stable. This one is not stable. This one is not stable. This one is not stable. So what it's going to do, this one is going to form another 3 bonds. Another board downward, then another board somewhere, but I'm not showing because this one is not drawn in the 3D scale. Then this one is also stable. This one is stable because have this board, and this board, and this board. So it's having 4 board, but it electron, the carbon that is forming a board, they are not stable. So again, they are going to join with others. And at the end of the day, they are going to have a structure, and this is structure of diamond, a structure of diamond. And this is what we call a giant convalent structure. It continue on and on and on in 3 dimensions because each carbon must have at least or at most 4 electrons for it to be stable. So because it's required for this one, if I'm stable, then you are not stable. You need to find other avenues for you to be stable. But the other friend that you got is not again stable. He or she need to find another avenue for her or he to be stable. So this chain again is going to continue on and on and on. It is going to be in 3 dimensions. It's not a molecule because the number of atoms joined up in a ring diamond is completely variable and depends on the size of the crystal, the diamond crystal. The reason it's not a molecule because we can say molecule always contain fixed number of atoms joined by covalent bond. Molecule contain a fixed number of atoms joined by a covalent bond. But for this one diamond does not have a fixed number of electrons or a fixed number of atoms as the joining continue on in endless chain. So that's why it's not a molecule. It's not a molecule. But don't forget, because it's not a molecule, it has covalent bond, which are very strong to be broken. So, and that's why we say if this covalent bond is very strong to be broken, then the melting point and the boiling point will be very high. So we can say diamond has a very high melting and boiling point. And this is the reason. This is because of very strong carbon-carbon covalent bond. Carbon-carbon covalent bond. We are writing that word, carbon-carbon covalent bond, which extends throughout the whole crystal in 3 dimensions. And this crystal or this 3 dimension is endless. So these covalent bonds are so many attracted together. So for you to break this, a lot of energy has to be supplied to break this strong covalent bond. Therefore, diamond has very high melting and boiling point. So this is the difference. It's important to realize this one. That's from a simple molecular structure that we saw above. In order to melt or boil a substance with a simple molecular structure such as methane, we only have to supply enough. We only have to supply enough energy to break the relatively weak intermolecular forces. Intermolecular forces, we say, this is the force of attraction between molecules. The force of attraction between molecules. In diamond, there are no intermolecular forces. So if there is not intermolecular forces, going to form a giant structure with no molecule. When you're going to have a giant structure with no molecule, that's why you're going to have a very high melting and boiling point. So let us conclude by saying this. In general, all substances with giant covalent structure are solids. But remember, the simple molecular structure, we said that most of them are liquid, like water, and others are gases, like methane. But those with giant covalent structure are solid, and this solid has a high melting and boiling point because a lot of energy has to be supplied to break or to weaken or to overshadow all the strong covalent bond throughout the giant structure. Other substances with giant covalent structure include you have graphite. Graphite is a carbon, but this carbon is not as that of diamond. So, and silicon dioxide, Si dioxide. Silicon dioxide is also a giant covalent structure. And giant covalent structure, not this, it's not a molecule. That's why it's very strong. So, you need to note that. So, any question?
No.
So, if there's no question, and because of time, we are going to end the class at that point. So,
Yeah.
for us to have the other class. So, have a nice day. See you in the IT class.
Bye.
Bye bye.
Space.